So our first question, we're just going to solve this equation. So I want to get x by itself on one side. So first thing I'm going to do is go ahead and add 9 to both sides, and that's going to give us 6x squared equals 60. You want to get x totally alone before you take a square root, so we're going to divide both sides by 6. X squared is going to be equal to 10. And when I introduce a square root into a problem to help me solve it, I have to put that plus and minus symbol in front of it. And in this case, the 10 does not break down, so that's simplest radical form. So my answers are positive and negative square root of 10 for that first question. Second question, this is just a FOIL, or you can draw yourself a box if you prefer that. I just think of it as a double distributive property. 2 times 2 is going to give me 4. 2 times 7i is going to give me 14i. Now, negative 7i times 2 is going to give me negative 14i. And negative 7i times 7i. Negative 7 times 7 is negative 49. I times I is I squared. So these terms in the middle actually cancel out. And the term on the end is negative 49i squared. So the key to doing this question is to remember that I squared has a definition of being equal to negative 1. So this term on the end here is really negative 49 times negative 1. So it's really 4 plus 49. So ultimately my final answer is just the number 53. Before I simplify this expression, I want to see if I can simplify inside the parentheses. So if you take the square root of a negative, it's just going to write an I with that. So negative 64 under a square root would just simplify to be 8i. That had a negative in front of it. Notice that doesn't change. This is actually an addition question, so make sure you don't multiply and do FOIL on this or anything. Now, square root of negative 81 is 9i, so I'm just going to simplify that. Again, that negative sign in front doesn't change. I'm just rewriting the square root of 81 with a negative under the square root is 9i. Okay, we're just going to combine like terms here. So 3 minus 8i plus 7 minus 9i. Put your real numbers together, so I've got a negative 3 and a 7. So that's going to give me 4. Negative 8i, negative 9i together, negative 17i, and it can't get any more simplified than that. For number 4, you have a couple of options, but we're supposed to solve the system. So I'm going to make sure to definitely remind myself that my answer should have an x and a y value. This would be easy to use substitution or elimination with. For me, what I'm going to do, I'm just going to use elimination, because all I would have to do to get a variable that would match up and be opposites is multiply that top line by negative 5. I'm just going to write it right underneath here. This would be negative 5x. Negative 5 times negative 4 would turn that into a positive 20y. Negative 5 times 5 is negative 25. Now, in this situation, this is kind of interesting. All these terms, these cancel, these cancel, these cancel. So how do I answer the question? Well, I end up with 0 on the left side and 0 on the right side. All right, that is a true statement. If all your variables have canceled out and you end up with a true statement, that means these two equations in our system were the same line. So the answer to my question is infinite solutions, because if they're the same line, they have every single point in common. So infinite solutions, what we're looking for in number 4. Number 5, another way to write this, f of x plus g of x. Not multiplying anything here. F of x is just 9x minus 4, and to that I'm going to add the g of x function, which is 7x plus 3. We're literally just combining like terms. 9x and 7x going to give you 16x's. Negative 4 plus 3 is negative 1. And that's as simplified as I can go for that question, 16x minus 1. Write the quadratic in vertex form, so I better remind myself of vertex form. It's y equals a times x minus h squared plus k. hk in that formula is the vertex. And a is the same in standard form and in vertex form. So I'm going to start writing this here real quick. I can see the a value is 1/3. So I right now I already know the a value, all we need to find are the h and k. Okay, so to find the x-coordinate of the vertex, if you guys have standard form, it's just negative b over 2a. So for this question, negative b would be negative 18 over 2 times the a value, which would be 1/3. Okay, we've got negative 18 divided by 2/3. Now, if you're going to type this in your calculator, be real careful that you put parentheses around this. I'm going to show you why. Negative 18, whoops, divided by 2/3. I'm just putting that 2/3 in parentheses. And that should be my answer. Now let me just show you real quick. If I had not used my parentheses, I would have gotten a totally different number. So be careful with that. You need to divide by the product of 2a and the bottom of that fraction. So you need to multiply the 2 times the 1/3 and make sure you put that in parentheses. So negative 27, that's the answer that I should have gotten for my x-coordinate. So negative 27. Now, if you guys remember, all you have to do to get k is the y-coordinate of the vertex. So if I know the x-coordinate of the vertex, I'm just going to go through and plug that in everywhere I see an x. So negative 27 squared, 18 times negative 27, and then minus 4. Okay, see if I can lay this on the screen so you guys can see it. This is going to be a huge number. I would put, as you're doing this problem, let's put the 1/3 in parentheses just in case, times negative 27 squared on the outside. That's really important, otherwise it'll not give you a positive number, which it should. So 1/3 times negative 27 squared plus 18 times negative 27, and then minus 4. Just go ahead and hit equals. And you get a huge number here, negative 247. That's going to be the y-coordinate of the vertex. This is also the value for k. So I'm just going to plug these guys in. My vertex, negative 27, negative 247. Plug these into the formula. Now, this is x minus h. So if that's my h and that's my k, this is going to be minus a negative 27. So it'll look like positive 27 in the equation. K, it's just plus k. If this is negative 247, it'll look like a negative 247 in the answer. And there's my equation in vertex form. All right. For number 7, it just says for each of the following polynomial equations, state the number of solutions. So the number of answers a polynomial equation has is just going to match the highest degree. So all you got to do is look at, we've got this in standard form, pick out the highest power of x. This is 5x to the 4th. This should have 4 solutions. Doesn't ask you if they're real or imaginary, just says state the total number, so that'd be 4. For my little example right underneath, it's the same thing. It's the highest power of x is going to match the number of solutions, or the degree of the polynomial. So that one's 7 solutions. For number 8, it says for the polynomial, state the intervals of the domain for which the graph is positive and negative. All right, whenever you're going to do any kind of intervals, positive, negative, increasing, or decreasing, we're talking about x values, and we're going to move from left to right on the graph. Now, what I like to do is I like to grab a highlighter and kind of highlight the parts. So positive is where the y values are positive. So anywhere this graph is above the x-axis, it's going to be a positive interval. And anywhere the graph dips below the x-axis, that's where our y values are negative. That's the part of the graph that is considered negative. So I like to actually kind of draw this right on the graph. So I'm going to come from negative infinity. I'm going to come from the left. And this whole time, if I would be sliding across the graph, it's above the y-axis until I get right to that point, which is negative 1.5. These do switch over at the zeros. So that's actually my first interval. So for my positive, from negative infinity until I hit that negative 1.5, that graph was positive. Then we dip below the x-axis. So as I keep going over here, this is negative, negative, until I get to the 2. So then that's my next interval, and that one's going to be negative. So that's starting at the negative 1.5 and stops at the 2. Now from here, the graph then starts to go above the x-axis again. And so since I have another positive interval, just use a little union symbol in between. So from 2 all the way until I get over to 7, that interval there is going to be positive. And these are parentheses here, just if I didn't say that, because if you're at 0, you're not considered positive or negative, so we have a parenthesis instead of a bracket, because we're not equal to a positive or negative value when our y-coordinate is 0. Now, this is a little tricky. So the last part of this graph, I'm not trying to confuse you, I'm traveling to the right. So we're traveling from left to right when we define these intervals. So I'm going to go, for the rest of the graph, would go to positive infinity for my x values. The graph is pointing down, and so sometimes people confuse that because the graph is going to negative infinity in terms of the y values. But we're just talking about where is the graph positive or negative. So the rest of this graph is negative as I travel to the right. So the actual interval should be second negative interval, and that's from 7 to positive infinity.